Hello and welcome to our AFT xStream Quick Start Video Tutorials series, Video 4. In this video, we are going to discuss how to define the pipe sectioning and output group and the transient control group. This video picks up where we left off in Video 3, with the fluid properties group and the pipes and junctions group defined. Open Analysis Setup and go to the pipe sectioning and output panel to complete the pipe sectioning and output group. AFT xStream uses a solution method called the method of characteristics to perform the transient calculations. In order to use this method, the pipes in the model need to be divided into segments, called sections. The pipe sectioning and output panel is where the minimum number of sections per pipe is defined. The pipe with the fewest number of sections is called the controlling pipe. The sectioning of the entire system is effectively controlled by this pipe. Note that very long runtimes are often a result of a large number of sections. This means using more sections in the controlling pipe increases the runtime. In fact, runtime is approximately proportional to the square of the number of sections. For example, choosing 4 sections of the controlling pipe will result in a runtime that is 16 times longer than if the controlling pipe only had 1 section. Another important fact to consider is the sectioning effect on accuracy. Increasing the number of sections in the controlling pipe will increase the result's accuracy. Therefore, it is advised to perform a sensitivity analysis on the minimum number of sections to determine the minimum section count that will result in sufficient accuracy. In this model, the minimum number of sections will be set to 1 for expediency. It is recommended to use more sections for real projects. The other required input for pipe sectioning is the estimated maximum pipe fluid temperature during transient. The maximum temperature is used as part of the time step calculation when setting up the method of characteristics solution for the transient solver. An estimation must be made since the maximum pipe temperature is not known before the simulation is run. Choosing a maximum temperature that is much higher or much lower than the maximum temperature calculated during the run can result in additional uncertainty in the MOC solution. It is advised to use a conservatively high estimate initially to improve model stability. After the initial run is completed, the results can be used to refine the input for the maximum pipe temperature. For this model, enter 1700 degrees Fahrenheit. We will move on to the simulation mode duration panel of the transient control group. This is where you can toggle the simulation mode between steady state and transient, and where you can specify the start and stop time of the simulation. Change the time simulation selection to transient and enter a stop time to complete the transient control group. I will enter a stop time of 240 seconds to complete this panel. Now, all groups in Analysis Setup are complete, and we can run a transient simulation. Click OK to save and close Analysis Setup. Note that the status light is now green, meaning the model is ready to run. In summary, the pipe sectioning and output group and the transient control group allow you to specify the transient settings. Use the pipe sectioning and output group to define the outputs needed to section the pipes in the model so the solver can use the method of characteristics. Use the transient control group to change the time simulation mode and to specify the simulation duration. Thank you for watching, and feel free to refer to the other topics in our AFT xStream Quick Start video tutorial series.